Okay, so for this lesson, we are basically continuing 4.5 day 1. If you notice, it's set up a little bit differently, and then we have this information over here. And so this is the worksheet. I need to go back to the notes. All right, so when you had to do these solving differential equations, the first thing you wanted to do was move that dx over to the other side. And the next thing you wanted to do was integrate both sides. So what we're doing here is y equals, all right, and I'm going to move that 24 to the front. We know that we can always do that with any number, not with x, but with any number. Okay. Now, this is what we had yesterday's lesson, okay? And if you were not here yesterday, you need to go back and watch that video. So what we saw was we could simplify this algebraically and integrate it like normal. Or we could notice that when we have an item in parentheses being taken to a power, let's set u equal to that thing. And then when we derive both sides of this expression, this would be 6x. Don't forget the dx. That was new. That was kind of a little bit of getting used to. What we're hoping for is that something over here matches all the other stuff in the problem. Okay? So here's an x. Here's the dx. All right, so let's think about this. We have y equals, we have 24. That's just going to get multiplied to anything else. We have our integration symbol, right? And then in place of the 3x squared minus 1, we have a u. So I'm going to go u cubed. All right, now remember this x and dx, it's going to be replaced, except the 6 is in the way. So how did we get rid of that? We divided it over to the other side. So replace the x and the dx with what they're equal to, which is 1/6 du. All right, and so the way we took care of this, I got a 24 here, don't mind that, it just gets multiplied. Let's move the 1/6 out in front, and then now we have a very simple integral that we can do. So this is going to be 24 times a 6, that's going to be 4. And what would be the antiderivative of u cubed? That's going to be 1/4 u to the 4, and then don't forget plus c. And then the last thing we did was we cleaned it up a little bit. In this case, a 4 times a 4th, that goes away. The u is 3x squared minus 1 to the 4th plus c. Okay, and this is where we stopped yesterday. What we're going to do this time is, actually I'm going to switch to yellow here, we are going to apply what we call the initial condition. This is the same thing like when you saw f of 0 equals 0. Okay, so this means I'm going to plug 0 in for y, and I'm going to plug 0 in for x, and we're going to solve for c. Okay, so that's a 0 equals, this is like what we did before the test. That's going to all become 0. -1 to an even power is going to be 1 plus c. So that means that c is -1. So my final answer is going to be y equals, I'm just getting this from over here, parenthesis, 3x squared minus 1 to the 4th. Instead of plus c, I'm going to write minus 1. So essentially, the day 2 stuff is just going ahead and solving for c. All right, let's try this again. If you're watching this video and you didn't quite get that, went too fast, go back and rewatch it. Okay, here we have a y prime. Sometimes we have a y prime. What we need to do in that case is replace it with a dy over dx. Okay, we also have things on both sides of the equation. Remember, we want to separate the variables. So moving the dx over is great, but I also need to move the sine squared over. Okay, so watch what I'm going to do here. I'm going to divide by sine squared x, and I'm also going to move the dx over. All right, now, do we know how to integrate this? Hold on just a second, sorry. Okay, thank you. All right, what I'm going to do is just use some things that I know about trig. Okay, this is where knowing your trig identities is helpful. I could do cosine over one of these signs to be cotangent And what's the other sign in the denominator, like 1 over sine? That would be cosecant. Okay, so again, I did cosine over sine to get cotangent, and then the extra sign in the denominator is a cosecant. All right, and then if I integrate both sides. All right, now you may be thinking, well, I know that this is a y equals over here. Over here, what am I supposed to let u equal? Well, you don't have to let u equal anything, okay? What we can do instead is say, this is one of my 6 trig derivatives. All right, what was cotangent cosecant the derivative of? All right, if you think back to our 6 trig derivatives, it was the derivative of cosecant, except we need to put a negative in. Okay, so I didn't need u substitution because this was something that I knew about. All right, there is another way, if some of you are thinking or tried this on your own before you watch the video, there is a way to possibly do u substitution where u equals the sign here, and then the du is the cosine. Okay, there is a way to make that work. This is much easier though, okay? And so if you know your 6 trig derivatives and you know a little bit of your identities, it makes these problems a lot easier. You don't even have to use u substitution. All right, so that's it. The only thing I need to do from here is to go ahead and use my initial condition. All right, so that means I need to plug 0 in for y, and I need to plug pi over 6 in for x. And so this means I need to figure out what is cosecant of pi over 6. Well, sine of pi over 6 is a half. And so cosecant would be flip that, so that would be 2. Draw out a triangle if you need to for that. Okay, I'm not going to go over that in this video. So then c itself would just be positive 2. So my final answer, and I'm just rewriting it from here, is negative cosecant x plus 2. Okay, so this is a problem where you could have used u substitution where you let u equal sine x. This, knowing a little bit of trig, got us out of that. So we're going to start getting into problems that you can do more than one way, and we'll talk more about that when I get back. Okay, so example 3. Still the same thing with the y prime. We need to replace that with a dy over dx. Okay, likewise, we need to only have the y's on this side. So I need to divide by that x square root of x squared plus 1, and I need to multiply by the dx. So then when you integrate both sides, okay, the left side is clearly going to be y equals. Okay, now let's think about this. Maybe we want to rewrite it. Let's write it like this, where the x squared plus 1 is being taken to a negative half power. This, I think, makes it a little bit easier. Okay, because now we have something we can do u substitution. And how did I know? Because I can't integrate this otherwise. That's how I know I have to do u substitution. Du would be 2x times dx. And if you notice in the problem, there's an x, and there's a dx, and there's an x, and there's a dx. Divide over that 2. Okay, so we have y equals the integral of u to the negative 1/2. And then in place of x and dx, I'm going to put in a 1/2 du. The 1/2 is clearly going to go to the front, okay? And some of you I know are probably already writing it like that each time. Let's go ahead and integrate now. Okay, 1 over, let's write our u. Let's add 1 to the power because we're anti-deriving. That would be positive 1/2. That's the number that's going to go down there. And then plus c. Let's clean it up and substitute back in for u. So 1/2 times 1 over 1/2, however you get there, that's a 1. So I don't even really need to write it, okay? It basically all cancels out. All right, what's the u? It was x squared plus 1 to the 1/2 plus c. This is the general solution. Is there any initial condition? There's no initial condition here. So this is as far as we could go. Okay, so on some of these solving differentiables, it's really just the same as what we did before. Just remember, replace y prime with dy over dx, make sure that all the x terms gets multiplied or divided over to the right side, integrate both sides, use u substitution where necessary, and find c when necessary.